push notifications is a word that I think we all know, but we might not understand fully what that means. So push notifications is basically what these things, you might think these are push notifications, but actually only one of them is a push notification, because only one was pushed to the device, which is why it's called push notifications. Whereas there's another type of notification, which is a local notification, which might be generated when an application just creates one, when it decides to create it. So that's like a local notification. We wouldn't be talking about those today. So today it's only about push notification, like a messaging app or a banking app telling you you have a new message or a new transaction. So this is a push notification, but this is, it might not be, it depends on the implementation. It's probably just a scheduled local notification for the time. So yeah, and I guess let's go to the next slide. So today, these are like a few things that I thought would be good to cover. So one is like a bit more about push notifications, and then the other one is Flutter running on Android and iOS. These things actually run in an application. So a Flutter application running on Android is an Android application. It has to follow the rules of Android. It has to follow the APIs, write an Android manifest. If they don't do these things, they can't ship to the App Store, and so no one can install it. So these Flutter apps are Android apps and there are iOS apps, but they have a Flutter embedded inside it. So we're going to talk about how does that embedded Flutter run with the platform or the host, and that's also about the communication. We have a Flutter world where we write in Dart, different programming language. How does that talk to the Android host or the iOS host? By maybe you want to request permissions for notifications to show them. You can't call a Dart function because somehow you need to talk to the OS. And then also push notifications in Firebase. Firebase messaging is a very popular messaging solution to send messages to your applications, and it's very good. There's a slightly simpler way of doing it, which is like a more simple architecture, and we'll discuss that. And then I also wanted to share some API design challenges and tips I faced as well over the past working on SDKs. So cool, let's get started. So this is the architecture diagram for push. You have the push coming into the device, and that's what push notifications are. But a more complicated architecture is this. This is a picture of the FCM, the Firebase Cloud Messaging Architecture. So you have a trusted environment, your server or an administrative app, and you want to push a message to your iOS app or to your Android app or to a web browser that your user owns. So you have a key that will allow you permissions to send these messages to those clients, and there's SDKs to do that, or you can go through an HTTP API or an XMPP API, or you can also make an application like a GUI. So someone like a marketer who wants to share their messages with specific customers, pick a specific segment, you can make an app for them, or Firebase also has some cool things for that as well. So so that's kind of the architecture for Firebase Cloud Messaging. I guess the one thing to note is on Android, that's your only option. You have to go through FCM. On iOS, your only option is APNS. So if you want to use FCM on iOS, what they do is you go through FCM, and then you go through APNS. So it's just kind of wrapping that functionality for you so that the interface to that to push notifications is consistent between Android and iOS and web. It's really nice because if you have an API which is different on iOS and Android, you're going to have to code that. You're going to have different logic, and if the behaviors are significantly different, it's difficult to code around those issues. So the next slide is, I just wanted to have a slide full of text here because push notifications is quite interesting. We won't go over how to implement these things, but for example, when you ask for consent to show notifications to the user, on some platforms you have to ask for permission to show. iOS is that example, web is like that as well, but Android isn't. You can just show notifications whenever you like. And it's like, if someone doesn't like your notifications, they can disable it, but by default, they show up. And then another one is what kind of push notifications do you send? Like marketing stuff, or just transaction stuff if you're a banking app? When do you send those, or do you have to ask permissions for different types of messages? You have to think about it. These are kind of business decisions. And then also, should you send notifications to all the devices? Because if a user has 4 devices, you're going to send to all 4. Maybe depending on the type of message you're trying to send, that might be really annoying. Another thing is maybe the user is already using that app on one device. If you automatically send notifications when an event happens, like something gets withdrawn from their bank account, that's going to annoy them because they're going to have 4 pings across all devices, even when they have an app already open. So another thing is if you're a banking app and someone disables push notifications, or there's maybe a vulnerability in the OS which allows them to disable push notifications, how do you fall back to make sure that your customer is still safe and informed about certain transactions? So you can then fall back to SMS to make sure that that's done. And also, when someone taps the notification once it's delivered, what do you do? And by default, the notification will just open the app and open it to the home screen. But sometimes you want that to open to a transaction page showing where the money went, or the chat that I was talking to with my friend, for example. So yeah, let me go back to the slideshow. So that's just the business base, which I won't really talk about. And now I'm going to talk more about the technical side of how the Flutter kind of talks to the platform. And to do this, it's pretty easy. So you have a Flutter app and you want to talk to Android or iOS. You just instantiate this thing called a method channel, and then you set the callback on the other side. So on the Dart side, you can create this method channel. On the iOS side, you create a method channel. And then you call methods on this method channel, and it will just call the other side, and you can handle that with a callback. And you can send it from the host, the Android or iOS, to Flutter, or the other way as well. Yeah, so this is basically some code. You instantiate that method channel, and then you invoke a method. So you don't just, because we're living in 2 different environments, like Android, iOS, compared to Dart, we can't just call methods because the symbols aren't there to call, right? Because they're different programming languages. So you just invoke a string, basically. You invoke a method with this string. And then on the other side, and this is Kotlin code on the Android, that's Dart code. On the other side, you basically handle it. So if the call.method is get battery level, then you call this kind of Android API get battery level, which is the system kind of APIs to actually get battery level. And then you can return that with result.success with that value. And if there's an error, you just do result.error. But the problem with this is now there's no static checking here. What happens if you call a method which is get battery level -1 or something by accident, and here it's listening to the wrong one, it's just going to go into this thing, not implemented, and you'll get an error. So there's not much type safety here. So what you can do, there's another framework or library called Pidgin, a package for Flutter, and it will generate all this code for you, so you wouldn't have this kind of bug if you mistype these strings, basically. So let's see. So this slide is about how do you actually handle that push notification. So like I said, it's pushed to the device. So how does that look in practice? You set a handler, basically, like a method which will be called when the OS says, okay, you have a message now.
So do I understand you correctly? The reason why we're worrying about method channels and all this stuff is because the push notification arrives in the Android or the iOS side, not the Flutter. So we need to receive them in the native iOS Android and then somehow push it up to Flutter. That's why we're worried about this.
Yeah, exactly. So these are the different handlers which would be called back. So on Android, you have to implement this Firebase messaging service class, and I call it messaging service, and you override this method. You also have to add something to the Android manifest, which is to declare that this is listening to something. And then this method will just be called whenever the admin sends a message to this app. And then on iOS, it's also the same. So on iOS, this is they call the methods differently. So you don't call this method application. You actually call this method, more commonly you would say, the did receive remote notification handler, which is actually the second kind of parameter of this function. But that's just how you call methods on iOS, because there are plenty of methods which start with application on iOS. So you basically you get the remote message in iOS as a user info, which is just a dictionary. It's just like it's a key and a value that can be any type, and the key can be any type except it has to be hashable, which just means it can be put into a hash map or it can be actually hashed. And so, but on this side you get a different type. It's a remote message. So the remote message is more useful. It contains things like the sender ID, the message ID, and a priority. Whereas this doesn't tell you much. It's just like the actual data that you send. So how do you make sure that these are consistent in Flutter? We have to send, now we use those method channels, and tell the Android, the Flutter side, like, this is the message that has arrived. So these are some documentation if you want to see how to implement that yourself. Oops. So it's even more complicated to debug this logic flow because the message comes in on Android. It might not even hit your app. It might just be like rejected by the operating system, and so that you have to debug that. And then once it's arrived on your Android app, you have to debug how does it go to the Flutter app. So in Flutter, you can debug the app in two modes at the same time. So have an Android Studio window open with the Android side of the app, and then have another debugger open for the Dart side, and then have them basically running at the same time. And then you want to also handle background messages, what happens when the app is terminated. That's quite an interesting case, which I wanted to mention, and also handling notification tags. So this is how, like, this diagram here is how Android and iOS host the Flutter app. So I guess this is the Flutter app, and it can communicate using method channels on the Android host and the iOS host. But on Android, the application is launched as part of an activity. An activity is a UI which is shown to the user. So if someone presses a home button, the actual application icon, they launch an activity. But if a push notification comes in, you don't want a UI to be launched all the time. In fact, you don't want any UI to show up. So in that case, because it's not an activity when that happens, the Flutter view doesn't get launched on Android. So your Flutter application doesn't run by default if a message comes in. But on iOS, because the whole application delegate, a delegate is just something to handle your application lifecycle, things like this application started, this application has been paused or killed. The Flutter view controller, which is the iOS version of the Flutter view, it gets launched all the time. So even when the message comes in, it gets launched. So you can rely on your app state to be launched. This is quite a significant difference between the two, and so this is how Firebase Cloud Messaging, which is the popular library I mentioned before, how it handles that. So it actually, this is your Android. It hosts a Flutter application inside it, and then it actually saves a reference to a method, the callback, which will handle your method. So you might, implement a callback. It will save the reference to that. In shared preferences, it'll just be an integer, like pointing to somewhere in your binary, because Flutter apps are actually compiled to binary and then shipped on the device. So that's actually the method. It's shared preferences is like a small little database, a file where you can put stuff in. So the reference to the method is stored in the database. So I put 2 arrows here because there are actually 2 references. So one is the callback, and then one is the user's callback. So one is the Firebase messaging callback, which will call back the user's callback. So it's quite complicated. There's like 2 handlers, and then the Android. So the application, Firebase Cloud Messaging also keeps an Android service running constantly. If you know what an Android service is, it's a thing that is not connected to a UI. So if you want to do any background processing or a notification or play music when the app that doesn't show UI, you would launch like a service to keep that running. And what it does is it actually runs another Flutter application inside it. So not your Flutter application, but another kind of very simple Flutter application which has only one job, which is to handle the push notification, to call the callback. So this hasn't done any work yet, because I haven't spoken about what happens when the message gets sent to the OS. So we've had this kind of thing listening now already. The service is constantly running, listening. And so now when a message gets pushed in from Firebase Cloud Messaging, it tells the OS, and then the OS tells this broadcast receiver. If you're an Android developer, you know that's another type of component which listens for events in the OS. So the event comes in, and then it queues the event. The reason why there's a lot of queuing is because that's just the architecture they've gone for. It's asynchronous. So when you could receive like 5 messages at the same time, and in that case they'd have to queue it up, and then the Android service will pull from it, send that message to the entry point, and then this will call that callback. But because these 2 applications are separate applications, you don't have the application state. So things like if you don't set up your like repositories or services these aren't running in this callback. So that's all in the documentation. You have to be careful that a lot of people have kind of tripped up with this because they think they have their application fully running, but they don't. So this is the architecture that I kind of created it in this package called push. It's like a new Flutter package, and I would like to think it's quite a bit simpler. So the component still listens for the message which comes from the OS, and the OS basically pushes the message to this broadcast receiver, and then this broadcast receiver will actually launch your Flutter application if it needs to, because in Android, remember, it doesn't always get launched. So I just launch it, and then once the application is finished running it, it would just say, I'm done processing this message, now that I'll fill the application. And so this broadcast receiver, instead of it being synchronous, like before, and having a queue, like a queue and then having to store this reference, it's much simpler. And I think this is probably what like Firebase cloud messaging could be improved to do, especially because this architecture with Android service constantly running is a pattern that Android is trying to shut down. Like if you have an Android service running all the time, that's going to be consuming extra battery, and especially because you've got also like a separate Flutter application running all the time as well. So yeah, so this is so now the question is like, why didn't Firebase messaging just do that? It looks quite a lot simple. But there's one thing that some Flutter apps have like custom Android code. By default, there's no custom Android code when you create create a new Flutter app from a template. But sometimes you have to add iOS dependencies and you write code in the main activity. And if you write code in the main activity, that code, I won't run that code. When I go to run the application, I won't run that. So that, because the application won't get set up correctly, it will just basically crash. That's something I didn't think about until after I implemented this package. But the interesting thing though is that I can solve this for people if I just let them or ask them to implement their logic. Instead of tying it to the UI, clearly what they need is they need the setup logic to be tied to the application lifecycle instead of the UI lifecycle. Because they expect it to run even when the message comes in. So we have to allow them to do this. And unfortunately, the Flutter, the Flutter framework, it doesn't make that work quite easy. So yeah, there's some but there are ways to solve this, and I'm working on that. So yeah, these are the difference between the two architectures. So yeah, this package I've just open source on pub.dev. It's not ready for production because there are no tests and it doesn't have great types. Like a remote message has a sender ID and a bunch of more data, but I'm just sending the title, the body, and the dictionary, the payload. It allows Flutter developers specifically to use APNS, which is the Apple provider, without using FCM. So sometimes some companies don't want to use FCM if they don't have to, because they don't want to be tied to Google necessarily. But FCM provides a lot of functionality as well, so it's a trade-off to be made. You're going to implement a lot. With this package, and if you try to avoid FCM, you're going to have a lot more headaches than if you just use FCM. So this package, compared to the Firebase messaging one, uses up-to-date components. So instead of having a service which runs all the time, we just launch the Flutter app when we need to. It's a simple architecture, and it's also federated. So what this means is it's a type of Flutter package which other people can implement specific platform implementations. So someone could decide, oh, I want to make an implementation of push, the same API for Windows or Linux. So all they have to do is just create a new package and then declare some stuff that they're actually implementing my interface, and then they can just release their package, and people can now use my package on Windows. Even if I was dead, I didn't have to change any code, they can still use this. So it gives them a lot more freedom so that the packages can be kind of maintained for different platforms by different people. And yeah, it's available on this package, on pub.dev as a package called Push. I quite like that short name because some people have really long names. Yeah. And yeah, so now this is the final bit. I thought I would just give some API design tips, some random things I learned along the way when I was facing problems and trying to make this package. And the first thing is, the one I learned many times before, is if you read more code, you'll learn, you won't copy it because you won't copy and paste, but you will understand how they do things, and then from your perspective, you'll see, actually, I know this other thing, and I can make it better. And so, yeah, because if you didn't read it in the first place, there's no way I would have been able to get anything close to my implementation without reading Firebase Cloud Messaging's implementation. But I was able to spend more time on it and just iterate on that and simplify it more. And also, this is the next thing, is just don't expose functionality that isn't implemented yet. Sometimes we have a spec or a document that says we should implement this API because that's our task. And some people, or me included sometimes, I would just write the interface for that, that API, but then I'll get distracted and I'll be busy with implementing something else. And then I might just say, okay, let's commit this now because I'll get to it later. And then I'll never get to it because that feature might not be a priority. So you'll have methods like this. So a request method, which literally just throws an unimplemented error, because that's like the default case if you don't implement something. So a user, sometimes they don't read documentation. They explore it through the API and see, when they type in the class which has this method, they'll see, oh, request, let's see what that is. And then they'll call it, maybe they'll call it in an app, like that's running in production. And then that might crash the app, so that could be a problem. But in Flutter, luckily, something like this doesn't crash the app, I'm pretty sure. I mean, maybe it does. And another thing was another package which has kind of died at the moment for push notifications, is something called Flutter Apns. They implemented this method called a method to handle push notifications as well, and they wanted to handle background messages. So in the case where the Android app is not running at all, it's like terminated state, and then a message comes in. So then they have to launch the Flutter app, and eventually I was digging through. I was like, how did these people implement this method? And then I read. I dug down method by method. I saw this parameter on background message get passed in all the way from the top, and then into another class, and then into another class, into another class. And then eventually there was this configure APNs method. And then you can see the method here with a parameter on background message. And this is the full implementation of that method. So it doesn't use on background message. So that means this is completely ignored. So that means, it's actually very complicated to dig down through the code and determine this. So someone had a question on GitHub, and I just investigated, why doesn't it work? And then, this is my reply. So the next thing I wanted to say was, consistency is always valuable, but sometimes different platforms have different functionality. So on iOS, they do have, you need to request permission, but on Android, you don't. So why would we ask permission on Android if we don't have to? So
change in the Android 13.
Oh, really?
Yeah.
Okay, cool.
We're running it in.
Okay, that's actually, that's a good thing. But there are some features which are inconsistent between the APIs, but that will make it more difficult for the users to actually implement. So making it consistent will actually remove a lot of headaches because they can rely on the behavior to be consistent across all their platforms. So one thing I thought, there was an issue on Android where if someone taps a notification, they wouldn't actually get the title and the body of the notification. So they wouldn't see what the user saw. Like your code wouldn't be able to tell, what was the title of this notification? So it would look like this. You just have the data and the title and the body. But of course, what you can do is in the data, duplicate the title so that when the message comes in, you still have access to it here. So my temporary solution, or my solution at the time, was to just remove title and body from both Android and iOS. So Android and iOS. So on iOS, you get the title and the body. But I was thinking, just remove it and make it consistent so that then the developer will know, let's just put the title and body in the data. But then, going back to the principle number one is read other people's source code. There was actually a hidden property in this kind of data that comes from Android, which is the message ID. So when the message comes in before the notification tag, you can like cache that message, save it onto the disk, and then when this comes back, you can use the message ID to reload that message in the full message. So now I'm able to basically have title and body on Android as well. Basically, I guess you could call this the lowest common denominator. What I did there was removing title and body, where I'm making the experience worse for iOS. iOS developers could actually just use that, but I removed it. But I think that's more valuable in this case because it forces them to do certain things which will make the behavior consistent. And it's like a trade-off. Yeah, that can be improved too. So that's why I mentioned you say cache that message when it comes in before the notification tag, and then you reload that message. So yeah, I guess it has been a few minutes since starting. To recap, we mentioned like the push notifications is quite interesting. There's like a lot of edge cases you have to handle when someone opens a notification on one device. Like you have to call back or cancel the notifications on the other one. If someone keeps an application open, you have to somehow know that their application is open, so you don't send and spam them with notifications, even though they're texting their friend. And so, also the other thing was Flutter running on Android versus iOS. iOS, the application, the Flutter app actually runs all the time when someone gets a notification. But on Android, you have to launch it sometimes. And how do you communicate with platforms? You use this thing called method channels, and it's basically like passing strings. In that case, we didn't pass any data with the method call. I just had get battery level. But you could, if you wanted to make a network request, you could say get. You could pass that data through as well, and use JSON or some like more primitive data format, not your own classes. And then how does push notifications do it in Firebase? How does Firebase do it for push notifications? And how I do push notifications for this package? Don't use it because it's not ready for production. But you can try it. In some cases, it can be useful. If you want to really avoid APNS on iOS, like the company that I previously worked on this project, not this package, but a previous project for, they didn't want to use APNS on iOS because they didn't want to be tied to Google for devices like iOS devices. And a lot of companies like OneSignal also, they don't want to do that, they go directly. And so, and some API design challenges and tips. So I think that's it, that's the end of the line. Sorry.
How do you handle push notifications for, say, their device is off? You definitely want them to get this notification as soon as the device is off. How is that handled? Is it,
so that functionality will be provided by the the messaging service. So on Android, it will be FCM, and on iOS, it would be APNS. You could basically say the time to live for that message. So if the message doesn't get delivered, like how long will it last for before you'll just forget, and you want the service won't even bother sending it to the device. So that's I guess the thing again with Firebase messaging, if you use Firebase messaging, that API is the same. It'll be called like time to live or whatever the parameter is, and you send the message to Android and iOS all the same. But for APNS, time to live actually might mean a different thing. It might mean how long is it lasting on the iOS device after it's delivered, but hasn't been sent to the application. So it's been delivered to the OS, but not the application. So those things, both of them you could call time to live, but time to live before sending to the device or time to live before sending to the application. So that's like the different inconsistencies between the two. And that's why Firebase messaging is something that abstracts that type of inconsistency, basically.
and will you be able to go back to the link to your package?
So it's called, if you go on pub.dev and you just search for push, you'll find it.
I just sent it.
Oh yeah, cool.
I have one question. I did a lot with the push for development, and there the Chrome team made an attempt to implement something called the Modification Triggers Api, and that would allow you to define a trigger. And so on the device, you could say with your JavaScript on your application, you could set that trigger. And whenever that trigger is hit, so let's say you have a time-based trigger, and you say, okay, have on this day and at that time, I want to send a notification. It would then show the notification to the user. Is there something like this also in native development? Because the package, or they implemented it in Chrome, but it then faded away. So I don't think it's even implemented right now in Chrome. But I think the feature is pretty useful because you don't need Firebase or any service to send a push. If you have it locally, like a calendar, you could just register your push notification, and it will be shown at a given time.
So that's why when I had this slide,
Yes, exactly that.
yeah, this is like a scheduled notification. So natively you schedule like, I want it in this time. You can schedule like frequency, like how often and the time, and also like how like noisy it is. And you can on iOS there's something called critical alerts, and you can't do that as a normal app developer. You actually have to ask for like permission from Apple to say like my app wants to show critical alerts. So things like phone, messaging apps or alert apps can bypass even your like silent mode as well. So yeah, scheduling is possible. But the other thing is with FCM and APNS, I think, but maybe not APNS, you can schedule the notification for later as well. So you can just put it in and then it will come in later.
Yeah, but you need to be
Connected.
You need to be connected to the internet.
Yeah,
So
exactly.
that was the problem. If you're not connected,
Yeah,
you won't see it, and if you have it locally, it will just show up.
yeah, yeah.
But in order for local notifications in Flutter to show up, doesn't the app have to be running? If the app doesn't run, then its local notifications don't show up either, right?
I think it should show up because you would basically ask either there's an API or I think there's an API to just schedule notifications. So the OS knows it's an OS kind of primitive which you can use, and then it will just be launched. So actually, I had one question actually, which is that this thing web push. Like how? I mean, one web push thing that's very popular is like Gmail. Gmail is one of the few companies and products which actually use web push quite effectively. But I haven't really seen web push. Web push actually annoys me more than it serves me. Like when I go to a website, it's like this wants to show you notifications, but I never ask. That's another thing. Like don't force someone with these alerts. But yeah, have people enjoyed push notifications on the browser? That's what web push is.
Yeah, web push, I think the main thing that I have a website and I have both like an HTML app and a web app, and I was thinking, oh, we're doing notification and I was doing web push, but most people actually go on my website on iOS. And it was like, oh, the web push on iOS, and that's like I think a huge like a breaker for people like implement it.
Yeah.
The big way stuff.
But the other part that it annoys you, I think that could be solved if you just think what your user wants. If you just show them the push notification request, if he gets on the page first time, he has no idea about the service, about the product, about anything, and you will just show him the Chrome, he will decline it by 99%.
Yeah.
But if you, I mean, Twitter made it pretty cool that you have the little, this little tweet-like advertisement, and so you are already logged in, you see this, okay, I could have notifications on the browser, and then you could allow the website to send you push notifications. But the way it's implemented right now, in most cases, it's just not usable, not
Yeah.
very bad user experience.
I think why they do it. So yeah, these websites, they do it because they'll get maybe 1% of people accidentally clicking it, and then they'll get a free marketing channel.
Yeah, but
So-
they're 99% of the users.
Yeah.
Put money.
Yeah.
Yeah, but the problem is some people won't know how to disable it, and that's so they've got like a free channel into their browser for the rest of their their app. So I guess not everyone is able to go into the settings or search like how do I disable this crazy website from spamming me. And, yeah.
It's almost a sign that it's like a bad website or like almost like a spammy website if they add that immediately like I don't even trust the content, although I usually throw away.
That's the first thing they show me on the website.
Yeah. I have push notifications. Nope, go, leave. Goodbye.
Yeah, I think push notifications is quite cool, but today there's been like much cooler things like machine learning and stuff. But having said that, I see even LinkedIn, my push notifications still come in after messaging someone and receiving a reply on the browser app, but the message comes in like 2 hours later on my mobile app. So there's still...
I think Slack does it very well where you just use your mobile phone, it'll come in on the mobile phone, you just use the web, it'll come in on the web, like you can tell which device you're on. Like if you walk away from your computer, your phone and your computer, I don't know how they do it, but you go downstairs, all of a sudden they're like, yeah, you're away from your computer, mark your bed away, stop telling my boss to go away from my computer, please. And then actually says like on the phone, so-and-so just sent you a message. And I'm like, okay, very invasive, but brilliantly done.
Yeah.
Yeah, it's really